Electromagnetic spectrum. The visible spectrum. Light is a form of energy. The energy of light is carried in photons. Photons travel in waves, where each wave has its own unique wavelength, which will also give the light a specific color. These are the colors of the visible spectrum, or Roy G. Biv. Light waves are measured from the crest of one wave to the crest of an adjacent wave. This illustration shows how light waves are measured. Light waves can be as small as 1.0 times 10 to the minus 6 meter to 1.0 times 10 to the 8 meter. The wavelength is also given in nanometers. Where 1 meter is equal to 1.0 times 10 to the 9 nanometers, and 1 nanometer is equal to 1.0 times 10 to the minus 9 meter. The frequency represents the number of waves passing a single point per second. From the illustration above, it should be obvious that the higher the frequency, the shorter the wavelength. The frequency represents the number of waves passing a single point per second. All wavelengths of light travel at the same speed. The wavelength of light is inversely proportional to its frequency. That means that as the wavelength increases, the frequency decreases. The formula for the speed of light is c is equal to lambda nu, where c is equal to the speed of light, which is 3.0 times 10 to the 8 meters per second. Lambda is equal to the wavelength, and nu is equal to the frequency. Light is often described by its wavelength in a vacuum. Visible light ranges in wavelength from 400 nanometers on the violet end to 700 nanometers on the red end of the visible spectrum. And this is an illustration of the visible spectrum. Notice that it's only a small fraction of the complete electromagnetic spectrum. So most forms of electromagnetic radiation is not detectable by the human eye. Now for some practice problems. Violet light has a wavelength of 4.10 times 10 to the minus 12 meters. What is the frequency? Remember, the formula for calculating the speed of light is c is equal to lambda nu. In this case, c is equal to 3.00 times 10 to the 8 meters per second. Lambda is equal to 4.10 times 10 to the minus 12 meters. And we're looking for nu. So to solve for nu, we divide through by 4.10 times 10 to the minus 12 meters. And nu is equal to 7.31 times 10 to the 19 reciprocal seconds, or hertz. Practice problem 2. Green light has a frequency of 6.01 times 10 to the 14 hertz. What is its wavelength? Once again, we use the speed of light calculation, where the speed of light is 3.00 times 10 to the 8 meters per second, and that's equal to lambda times the frequency, which is 6.01 times 10 to the 14 reciprocal seconds. Solving for lambda, we must divide through by nu. So 3.00 times 10 to the 8 meters per second divided by 6.01 times 10 to the 14 reciprocal seconds. And in this case, lambda is equal to 4.99 times 10 to the minus 7 meters.